Okay, so now we have understood the concepts behind Panda's ways of building and supporting data frames and series. Remember the two-dimensional tables versus a snake-like kind of structure array. We are ready to play around a little bit more by going to the lab, our spider lab. Okay, here we can then do some interesting stuff like creating a new data frame and a series. Okay, so let's begin by declaring that we need to use NumPy and pandas. Now, a little bit of advice here. We alias it. We name NumPy as NP and pandas as PD. Now, although this is really up to us to call it, I strongly suggest you follow the same NP for NumPy, PD for pandas, because when you seek help online, Google, and you try to study other people's sample codes, uh, the Python community tends to always use this. All right, so whether you're sharing code or you're reading back, try not to deviate from this alias. Now we're going to also import random just to have a quick means of generating random numbers to fill up the cell value so that we don't have to crack our brain to think about um, all the random numbers. And there is a subset or submodule in random in NumPy as well. That's called random. So we're going to use that random instead. And we're going to use a seed mechanism, which is to kind of like setting the radio knob to tune into a particular channel, like 123 megahertz, so that even though I'm generating random number and you are going to follow me and generate random numbers, your random number is the same as mine. It's a bit like I tune into radio station 123 megahertz, even though the content is random, but when you tune into the same radio channel 123 megahertz, you're going to listen to the same random content as I do, right? So then that is a way to feel the randomness, but you can also then check against my screen to see if you're on the right track or not. Okay, so definitely have to do that. Then let me just try to show you how we can quickly and easily create a data frame. Now, it may look a little bit more intimidating than it actually is. So the idea is this. To create a data frame, all you need to do is to pd.dataframe open close bracket. That will create an empty data frame. Now, be careful about the capital D and the capital F. It's case sensitive. Okay. So here, what we are having is to supply the initial data, which is going to be a list, right? And it's going to be a list comprehension to generate 7 items. Now, what are these items? The np.random dot standard underscore normal is going to be generating 10 values that are based on the standard normal distribution. That means we have a mean of 0 and a standard deviation of 1. So you're going to see random numbers usually ranging from -3 to 3. Let's just try it out. So first we import numpy, then we import pandas. Okay. And then I can now run np.random and see what it says. So it is going to give me an array of random numbers, roughly, in line with the standard normal distribution. Now we see this array here. It's NumPy's way of saying that I have a list. Okay, why is it different from the list? Because Python's list, as we discussed earlier on, can have heterogeneous types. That means you can have string, integers, float, all mixed together. Not for NumPy's list. And to distinguish it, we call it an array. The array also in the computer science community of discussion tends to suggest, now there's no standard technical definition, but it tends to suggest that the cells within an array have the same data type, which is exactly what it says here. Now, your random number may not be the same as mine because we haven't run the random.seed yet. So it is okay, just bear with it. So long as you see 10 random numbers, some positive, some negative, that's okay. Now, what is interesting is this is an array. We can force it to become a normal list array by just wrapping it with a list command. And then we force it to be a usual Python list. Okay, so whether it is usual Python list or numpy's list, or which is called array, it is okay to be put in here. All right, so with the list or without the list bracket command, it is okay, acceptable. So pandas data frame command and much like pandas other functions are very versatile. It's able to absorb a lot of non-standard types, so long as it kind of makes sense. It's very intelligent in that sense. So we have a list comprehension here, and if you have studied the list comprehension video, you understand that it's going to repeat this. Remember what this does? This gives us a list. It's going to repeat generating this list 7 times for I going from 0 to 6, right? So what happens then is that in the big picture, it is a list of 7 lists. So that is basically a nested list, right? A 2D nested list, which means it is going to be a table of random numbers. So 2 by 2. 7 rows of 10 random numbers. So we should see a data structure having 7 rows, 10 columns. Since we're going to get 10 columns, we're going to label the columns. Now, again, labeling the columns is a bit optional, but let's label them so that it's not nonsensical to us. We can label it after df has been created by data frame function. We can do that later on by reassigning the label column labels. But right now, on birth, on creation of df, we can also give the column labels. Now, let's understand this. The list of a string is a quick way to decompose the letters into a list. So we should see a list of the letters as strings, which is what it is. So we should see column labels going to be A, B, C, D, E, capital, and A, B, C, D, E, little case. And then we run. Okay? So nothing comes out because we didn't say print or what, but we can interrogate and say what is df. Now you should see the random numbers, right? 7 rows by 10 columns in exactly the same digits. Not a single digit should be different. And if your number is different from mine, please comment on the video and let me know, right? Let me know your machine, the operating system, the version, the spider, that version you're using, the Python version you're using. And, it's going to be interesting if one of your digits is different. So if you're happy with the outcome here, then congratulations. We have successfully created our first data frame. Okay. Now, of course, like I said, we could have done something like pd.dataframe, and I'm just experimenting with it on the console, so I'm not changing the program with nothing. So a data frame of nothingness has nothing in the columns, nothing in the index, no body content. And that is not interesting except to begin a data frame for us to start to add more rows or columns and fill the content. So sometimes we need this, right? So as simple as that. Simple as that. And we can also run series. So for example, we can have a series of, nothing, right? So, and we get a warning. This warning is because if you are using the more advanced versions, the later versions, I'm using Python 3.8. If you're using earlier, you might not get this. And whatever it is, it's giving us a warning. It's not saying that we cannot do it. It's correct. So SS0 is nothing. What is SS0? A series of nothing. Okay. And the reason why there's a warning is because the series function has guessed, make a unreasonable guess that our data type is floating point 64 bits. And that's why there's a warning. we are not being clear in what data type. Remember what's a series? A series contains any number of cells, but they must be all of the same type. And you see therefore a data type, a D type. And that means what is the common data type for all the cells, now and in future. Okay. So to escape that warning, we can have a empty series, but provide a data type of int. Now it's silent because it's clear. We have a sort of an empty container of an empty series container of data type int, expecting integers to be set. Right? We can also to show you how pandas functions are pretty kind of smart. Even if you enter a string of int, it's not going to flag an error. Oh, wrong type. We expected basically an int without the quotes. That would be quite fussy, right? Because we actually are saying the same thing. Yeah. So this is why pandas is so, it's not so picky on the wrong things. It's very picky on noise in the data, unclear expression of what you want and what you don't want in the filtering, etc. So those are necessarily deserved for being more picky. But not here, not here. Our intention is clean, right? Like int or int string. So